Bn is 1 upon pi minus pi to pi f of x into sin nx dx. So let's substitute. That comes to be 1 upon pi minus pi to pi. My f of x is nothing but changes to range, so first I'll be saying as from minus pi to 0, my f of x is minus pi sin nx dx, plus from 0 to pi my f of x is nothing but x sin nx dx. So now after substituting I get 1 upon pi here as minus pi as a constant. Integration comes minus cos nx divided by n, where lower limit is minus pi, upper limit is 0, plus here I get my formula of u into v. So I get as u minus cos nx divided by n minus 1 minus sin nx divided by n square, where your limits are nothing but 0 to pi. Now let's substitute the limits. I get as 1 by pi, here minus pi by n as a constant, keep it outside, minus and minus becomes plus. So when you put cos 0 here, I get first as 1, and when you put cos of minus n pi, that comes to be minus 1 raised to n. So this is my first term, plus when you put upper limit here, that comes minus pi by n, cos n pi is minus 1 raised to n, minus and minus become plus, and anyway sin n pi will be 0. So that's my first limit, minus putting lower limit, this comes 0 and here comes 0, so that will be nothing but a 0. So finally solving, I can get Bn as 1 upon pi by n minus pi by n minus 1 raised to n minus pi by n minus 1 raised to n, so which comes to be 1 upon, I can take pi common, so pi and pi finally gets cancelled out. I get as minus and minus becomes here 1 by n, and here minus and minus becomes minus 2 minus 1 raised to n divided by n. So finally I can say my Bn to be 1 by n 1 minus 2 minus 1 raised to n. So that I got as An, Bn and B0. Let's substitute in f of x. So f of x will be minus pi by 4 plus, I can take first is An, that comes 1 by pi, I took it outside, summation n equal to 1 to infinity minus 1 raised to n minus 1 divided by n square cos nx. So that is just a substitution of An. Now next will be plus summation n equal to 1 to infinity 1 minus 2 minus 1 raised to n divided by n sin nx. So here I substituted my whole f of x. Now we need to deduce also. This we can say we have find out Fourier series of a function. Now we need to deduce also. For deduction, what I need to put, or first we will be just expanding this, that comes to minus pi by 4 minus 2 by pi. I'll be putting n equal to 1 to infinity. I'll be making a series that comes, first is cos x divided by 1 square, next is cos 3x divided by 3 square plus cos 5x divided by 5 square plus, and then plus I say 3 into, here comes sin x, that will be my first term when you put n equal to 1, minus 1 by 2 sin 2x, and then plus sin 3x, and then dot dot dot. Now this is my f of x. For deducing, I'll be putting x equal to 0. I say put x equal to 0, so that comes to be first f of 0, and here it comes to be minus pi by 4 minus 2 by pi. Anyway, sine series will be 0 because it is nothing but sine 0 is 0. So I say 1 upon 1 square plus, here comes 1 upon 3 square plus 1 upon 5 square plus dot dot dot. First we need to find f of 0 values.